Welcome to point 3, lesson 2.3 about solving multi-step equations. Alright, so welcome to the video. This is a video all about section 2.3 in the 8th grade algebra book. We're going to start off with just making sure you write down the goal for this one. Make sure you have the goal on I would write it on your goal sheet, if not on your notes. And either way, you're going to have to self-assess yourself on that goal sheet afterwards. So this is the goal. Remember, goal and objective are the same thing. So we're going to solve multi-step equations in one variable. Okay? So before we do that, I want to review a little bit of vocabulary and a couple other things that will help us with this section. So first of all, the first thing I want to review is the terms inverse operations and like terms. We're going to use both of those today. So inverse operations we talked about with solving even just one-step equations are operations that are opposites and they undo each other. So for instance, if we're talking multiplication, the inverse would be division. If we're talking division, then the inverse operation would be multiplication. Same thing for addition, would be subtraction, and then subtraction, the inverse would be addition. Whenever we're solving an equation and we're trying to undo something on one side so we can get the variable all by itself, all isolated, we have to use the inverse operation to undo whatever that part is. All right. The other term I wanted to recap is this is a term from chapter 1 is like terms. So like terms are terms in an algebraic expression that have the same variable raised to the same exponent. Sometimes there won't be exponents at all, but then they have to be the same, just the same variable. Or we can also deal with just numbers, which are called constants, would also be like terms. So let's review a couple things. First thing I want to review is the distributive property. We learned this in chapter 1. We're going to use this some more in chapter 2 when we're solving equations. So the distributive property in general, it just looks like this. You have something outside of parentheses, and then on the inside you have either addition or subtraction. So it has to be either addition or subtraction. You can't have multiplication in the inside and then do distributing. So when you distribute, you kind of take this A, which is on the outside, and distribute to both parts of the inside. So we do the A, multiplication is right here. So A times B is where we get that from. And then A times C, that's where we get that one. And then we keep the same symbol in between. Okay? So just remember, here is an example of that. We're going to take this example. The 2 is what's on the outside, and we do have subtraction on the inside, so that's fine. We're going to distribute the 2 to both things here. So we're going to do the 2 times the 3x. And we're going to keep that subtraction sign. We're going to do the 2 times the 4. Okay? So then you just have to simplify that, and you get 6x right here, because 2 times 3 is 6. And 8 right here. Now you'll see you can't do 6 minus 8, because one of them doesn't have a variable, and one of them does. So this is as simplified as we can go here. Okay? So that's the distributive property recap. Now let's do a little recap of combining like terms. So what can we combine? So the first question I have is, which ones of these are like terms? Well, we said like terms have to have the same variable, and if they have an exponent, have the same exponent to it. So for these, let's look for some things with the same variable. So I'm going to put boxes around anything with an a here, because we have negative 1a. I got just a right here, so that would be 1a. We got 4a right here. Looks like that's all the a terms. So that's all we have right here. Now let's put a circle around any x terms. That's an x. That's an x squared. So that would not be a like term. So don't get fooled. That's not a like because it does not have the same exponent. This would be an x term, so it's 5x. Let's underline all the x squared terms then. Looks like we have x squared here, or 3x squared, and 1x squared right there. And then whatever's left is just our numbers. So we have negative 2, 4, and 10. Those are all constants. So only the ones that have the same shape around them would be ones that you could combine if we were simplifying by combining like terms. So let's do a couple examples here. First one, is just a long expression. So I'm going to do the same thing that I did before. First one here I have is the x squared. So I'm going to put boxes around the x squareds. Oh, nope. Oh, and this would be a minus. Keep the minus sign with it. Minus x squared, or minus 1x squared. All right, I'm going to circle any of the x terms. Positive 3x and positive 1x. And then we'll just leave the constant terms there. We'll combine those as well. Well, we can combine minus 4 and plus 9. So let's do all the box terms. 2x squared minus 1x squared is just going to be 1x squared. Positive 3x. No, hold on. I'm gonna pull this apart here just to show you what I did. I did the 2x squared minus the x squared, or minus the 1x squared. And then I'm going to do that 3x and that 1x. And then I'm going to do that minus 4 and plus 9. Okay. So what you would end up getting here, and I can slide this up just a little bit. What you would end up getting here would be, this is where we got our 2 minus 1x squared. You can always put a 1 in front of it if there's nothing. You just have 1x squared left. Plus 3x plus that 1x would be 4x. Plus the negative 9 plus, or negative 4 plus 9 would be positive 5. So this is our simplified version of that, because we can't combine anything else because they're not like terms. Okay, so all that turned into just x squared plus 4x plus 5. Now, what we're going to deal with a lot in this chapter is actually combining like terms with equations. So we're going to actually have an equal sign here. And I'm going to bring this down a little bit. So this has an equation. Now, when you're combining like terms with an equation, you can only combine each side. So you can only combine, combine I gotta work on my writing on this thing. I apologize. You can only combine like terms that are on the same side. So like if you look at this example, I know there's a 5 over here and there's a minus 23 over on the right. They're on different sides of the equation, so you cannot combine them. So it helps just to divide this up here. You can do that. But we can look at anything on, there's nothing to combine over here. That's simplified. We can combine the 5m and the plus 2m. So then we have 5 equals, whoops, the doodles. There we go. And then we have the 5m plus 2m would be 7m minus 23. So it's just combining like terms that are on the same side, side of the equation. Okay? And then it's a two-step equation that you can solve. So that's kind of getting into what we're doing today. Just multi-step equations. You have to do one more step, or maybe more than one more step, before you can get to a two-step equation like we've been working with. So here are your new steps for solving multi-step equations, and these would kind of work for most equations. You can even use these for smaller equations, but you just wouldn't be doing the first one. So it says simplify each side of the equation. So that's where I said each side. That's where you can use the distributive property if need be, and the combining like terms then if need be. So if you see somewhere you can do the distributive property, I want you to do that first. Then combining any like terms on each side. Once you do that, we're just going to do the inverse operations. So we're going to do addition or subtraction first, like we've done. Then we're going to do multiplication or division last. So the only thing new here is this first part where we are first simplifying each side by either distributive property or combining like terms. So it's just could be one or two added steps here. So we'll do some examples. I'd like you just to watch this first one, and I'll have you write down the second one. So just watch as I do this first one here. Looks like I already almost did that one because this is the same one as just before. So if I have 5 equals 5m, So this is where I'm going to simplify. Is there any distributive property? No. Check. Is there any combining like terms? Yes. On this side I have 5m and 2m. So 5 equals, that would be 7m plus 23. There's no more like terms on this side or on this side that you can do. So check there. All right, now we're going to do the inverse operations just like a two-stepper with addition or subtraction first. So since I see addition over here, I'm going to undo that. We're trying to solve for the m, remember. So I'm going to undo this addition by subtracting 23 from both sides. This will cancel out. You'll just left with 7m to the right. 5 minus 23. Well, let's do 23 minus 5 is 18. And the 23 is a negative. And it's a bigger number, so it's a negative 18. And then your last step is to divide both sides by 7. Oh, I know what I did wrong. Hopefully you caught my mistake. I'm going to erase all that. Because guess what? I wrote this wrong. You got to be careful. If you might have noticed that I had ended up with something weird there. It would have been a weird fraction, but this is a minus 23 here. So that's what I did wrong. So I'd actually have to add 23 to both sides to undo that subtracting. And then I get a nicer number. This is gone. 7m equals 28. And then you can undo the multiplication. That's done. Oops. Whoa. As I was saying, we're done there. Now we can do our multiplication or division. So this is multiplication, so we're going to undo it with division. Divide both sides by 7 to get rid of that. So then we're left with m equals 28 divided by 7, which is 4. I want to stress, some of you aren't doing this, checking your answer. So plug it in for the original. We can plug this in 2 spots now. I'm going to do this in red. Plug it in for the m there and the m there. So we have 5 equals 5 times 4 minus 23 plus 2 times 4. So that's equal to 20 minus 23. The multiplication over here would be 8. Then I just go left to right. 20 minus 23 is negative 3 plus 8 is equal to 5. So 5 equals 5. Smiley face, because we did it right. So m is truly equal to 4 on that one. Now, this one I'd like you to actually follow along and actually do with me as well. Okay, so I want you to write this one down. We'll go back and forth between the steps if you need to, which hopefully you have written down. But we're going to try and do this one together. So this one looks like we're going to have to do some distributing. So why don't we, so it says first simplify each side. This one says use the distributive property first. So we have distributive property because there's something multiplied by something in parentheses, adding or subtracting. So we have negative 8 times 2x minus, because there's a minus sign there, negative 8 times 1. So that 2 minuses become plus. So we have negative 16x plus 8 plus 6 equals 42. Okay, done with distributing. Now, are there any like terms on either side? 42 is all by itself, so there's nothing over there. Looks like we have plus 8 and plus 6. So why don't we say that's negative 16x plus 14, since those are like terms, equals 42. All right. Done with combining like terms. Now let's do inverse operations for addition or subtraction. So we're trying to get the x by itself. So let's get rid of this plus 14 over here by subtracting 14. Trying to get the x by itself, remember. So that's gone. Bar there, you get 3. 12 minus 4 is 8. 3 minus 1 is 2. So 28 is equal to negative 16x. I'm just going to take a look and see if I made any mistakes anywhere before I'm done here. I think I did it right. We're gonna get a weird answer for this one. So last step is to divide. Since we're done with this one, we can then do our multiplication or division last. We'll divide both sides by negative 16, since that's in front of the x. And then x would be equal to, well, 28 divided by 16. Oh, why don't we just see what it says in the calculator? It's going to be around 1.5, but I think it's like 1.4, or negative 1.4 in this case. Oops. 28 divided by 16. Oh, wait, so negative 1.75. Now, how can we check that again? We can check that by plugging it back into our original equation for x. So we'd have negative 8 times 2 times 1.75 minus 1 plus 6 equals 42. Now we have to do the inside of the parentheses first. 1.75 times 2. Let's do that here. And minus 1. So it's going to be 2.5 inside of this parentheses. Times negative 8 plus 6. 2.5 times negative 8. I think it is 20. Negative 20. Yep, so that'd be negative 20. Whoa. Now that should be negative 14 equals positive 42. So that means, what did we do wrong? Let me just check this for a second. I know what I did. This is supposed to be a negative 1.75. So this would be negative 3.5 minus 1, which is negative 4.5. I apologize, it's going to look really messy now. Which should end up being negative 8 times negative 4.5 would be 36. And 36 plus 6 is 42. So then we give ourselves a smiley face. I apologize if you weren't able to follow that. I just plugged in 1.75 instead of negative 1.75. So if you do negative 1.75 in there, it will work out, and that is our solution then. All right? So what I'd like you to do then on your own is try to solve this one right here. We've got 10 plus 14 equals negative 2 times parentheses 3x minus 9. So follow those steps over here. You can use it as a checklist if you want. Follow those steps to solve that equation. And then I'd like you to also, this is the same one right here, write down the steps you would do to solve those in words. Okay, please write down the steps you would do to solve those in words. And I will do this really speedy if you want to check it, but I'd like you to pause it and check it on your own first. I'm going to do it really speedy and show you what it would be. All right, there it is all worked out for you. If you'd like to take a look at it and pause it. Don't forget, when you have this negative 2 times 3, that is a negative 6. I almost forgot to keep that negative with the 6 all the way down. Then you divide both sides by negative 6 in the end. But I did some combining like terms over here, 10 and 14, and then I did the distributive property over here. There's nothing else I could do to simplify, so then I just took it and did it like it was a two-step equation. All right, so don't forget to self-assess yourself on the goal sheet, and we'll see you next time.